Welcome back to Security and Privacy in Cloud. I'm Jay Lavanya, Assistant Professor of CSC Department. So in this video, we are going to discuss about Unit 5, Monitoring, Auditing and Management topic. Under this, we are going to see the subtopic called Monitoring for Unauthorized Access and Malicious Traffic. So let's dive into the topic. So what is meant by monitoring for unauthorized access? So this refers to the continuous observation of network traffic and system activities to detect some unauthorized access, attempts or malicious behavior. So if you take in today's digital landscape, the security of information system is a paramount. So this document outlines the importance of monitoring for unauthorized access and malicious traffic, providing insights into effective strategies and tools that can be employed to safeguard the sensitive data and maintain the integrity of networks. And by implementing some robust monitoring practices, organizations can detect potential threats early and respond to the incidents promptly and reduce the risk associated with the cyber attacks. So what are the importance of monitoring? So first one, early detection. Second one, instant response. Third one, compliance. And then data protection. So early detection is that continuous monitoring allows organizations to identify suspicious activities before they escalate into significant breaches. And what about instant response is that quick identification of threats enables a more efficient response, minimizing potential damage and recovery time. Compliance. So many industries are subject to regulations that require monitoring and reporting of security incidents. And data protection. Protecting sensitive information from unauthorized access is essential for maintaining customer trust and business reputation. So these are all the importance of monitoring. So apart from that, we have like what are the monitoring aspects then? Like performance optimization. If you take which helps in identify the bottleneck and underperforming components and which enables the load balancing and auto scaling decisions based on the usage pattern. And the compliance, as we have discussed earlier, like GDPR, HIPAA, and then availability and reliability is that which ensures services are running smoothly with minimal downtime and supports a proactive issue resolution before they impact the users. And cost management, which tracks the usage to prevent over provisioning and unexpected bursts, which helps to optimize resource allocation and avoid the wastage. And what about troubleshooting and root cause analysis is that which provides the logs and metrics that are essential for the diagnosing issues. So which accelerates the resolution of incidents by pinpointing the exact failure point. Okay. And what about user experience? So it ensures a consistent and high quality user experience by detecting and addressing the what is that by addressing some real concepts and then addressing like the performance issues promptly. Okay. And next is that automation and alerts, which enables automated response to certain events, example auto scaling or restarting events, and alert teams are immediately when threshold is breached. Okay, so this is the importance of monitoring. So here you could see some examples for cyber security monitoring. So here in framework, they will be using some kind of data integrity, as well as they'll be going for some tools and technologies like SIM or IDES and something like that. And monitoring practices which involve strategies to detect and response to the threat attacks which is possible in this cyber security. And the ultimate goal is to protect the digital access. So this is the main thing where it will be protected. So what are the strategies for effective monitoring is that? So these are the five important strategies for effective monitoring for unauthorized access and malicious traffic. An organization should consider the following. So the first one is that IDS and SIEM tools and conduct regular audits and assessment and monitor the user activity and analyze the network traffic. So first of all, what is meant by IDS? So an IDS can help or detect some unauthorized access and alert the security system out to the potential threat. By these system, it also analyzes the network traffic and identify the patterns that may indicate some malicious activity. And SIEM tool, so here SIEM tool aggregate and analyze the security data from various sources, providing a comprehensive view of the organization's security posture, can help identify anomalies and generate alerts for suspicious activities. Next one, conduct regular audits and assessment. So here, regular security audits and vulnerability assessment can help identify the weaknesses in the system and that could be exploited by the attackers. And this proactive approach allows the organization to strengthen their defenses and monitor user activity. So tracking the user behavior can help identify some unauthorized access, implementing the user behavior analytics, that is UBA, which can provide insights into normal user activity and flag the deviations that may indicate a security threat and analyze the network traffic. So here, like monitoring the network traffic for some unusual patterns can help to detect a malicious activity, and these tools provide some deep packet inspection which can identify threats that may not be visible through some standard monitoring methods. So these are the strategies for effective monitoring, and apart from that we have some other ways for effective monitoring, like one of the things is that we have to define some clear metrics and KPI. Like what is meant by KPI is that we can monitor like latency or the CPU usage or the memory or the error rates, etc. And we have to set the performance threshold based on the business objective, and we have to use some centralized monitoring tools. We have to implement tools like Datadog, Prometheus or AWS CloudWatch and or Azure Monitor. Okay, and set up automated alerts is that configure real-time alerts as well as for anomalies or threshold breaches, and we have to use some multi-channel alerts, example like email or SMS, Slack, etc. And enable log management and analysis. We have to collect the logs from all services and applications. We have to use tools like ELK Stack or Splunk to analyze and search the logs and implement distributed tracing is that we have to help trace the flow of a request across the microservices, and we have to use the tools like Jaeger or OpenTelemetry for visibility and monitor across multiple layers is that we have to use some infrastructure layer, an application layer, or the user experience, and leverage AI and machine learning. So we have to use some intelligent anomaly detection and predictive analysis for identifying issues before they impact the users, and periodically audit what you're monitoring, and we have to update the threshold metrics and alerts as your system evolves. Okay, so these are the some kind of strategies for effective monitoring. Okay. Next, we shall see about what are the key components involved in the monitoring aspects. So key components like intrusion protection system and then intrusion prevention system, firewall log, and then SIEM tools, example Splunk or ELK or QRadar, and then network traffic analysis, that is NTA, tools like Zeek, formerly which is called as Bro, which helps to influence flow and behavior of traffic for the anomalous. And we all know like intrusion detection system and intrusion prevention system, which we have already discussed in the unit 2. You can just check out that particular videos for some kind of clarification or like that. And next topic we are going to discuss is about malicious traffic. So any network activity that is harmful, suspicious, or against policy, it is called as a malicious attack. And malicious traffic in case of cloud environment refers to some intentional actions by threat actors aimed at disrupting, stealing, or damaging the cloud-based systems, data, or the services. And common types and example is that, so types of malicious attack, there are so many types. First one is that data breaches. So unauthorized access to sensitive data, which is often caused by the weak access control or misconfigured storage, example S3 bucket, and the denial of service, that is DDoS attack, that flooding cloud services with traffic to make them unavailable, which can disrupt the business operation and customer access. And my next one is that man in the middle attack. So here we are intercepting the data in transit between users and the cloud server, often occurs due to the lack of encryption or insecure networks. And next, like account hijacking, so gaining access to cloud user credential through some phishing or brute force attack. And attackers can manipulate the data or steal the information or launch some further attacks. And insider threats is that so employees or the partners with some malicious intent misusing their access or difficult to detect due to some legitimate credential. And insecure API, exploiting poorly secure API to gain unauthorized access, and API often serve as a gateway to the cloud resources. And malware injection, injecting some malicious code into a cloud service to take control or extract the data, and which can be embedded in some scripts or something like that where it will be embedded as a package. So this is all about thing. And so in order to prevent these kind of malicious traffic, so example is the malware trying to send the data from your computer to a hacker's server. So you can use some multi-factor authentication, or you can encrypt the data in a transit and address, and we can regularly update and patch system, and implement some intrusion detection system and monitor the use behavior as well as action pattern. So these are the tools for detection and monitoring. So first one, intrusion detection system. So here the main purpose is that intrusion detection system, it monitors and analyzes the network traffic for suspicious activity. And a popular intrusion detection system tools is that like SNOT, which is a signature peaks, looks for some known patterns of attack. And second one, Suricata, which is similar to SNOT but supports multi-threading and more modern protocols. And third is that OSSEC, that is host-based intrusion detection system, which monitors the file changes, logs, etc., Example is that a snort detects an SQL injection attack based on a known rule. Okay, and intrusion prevention system. Second is that intrusion prevention system. So here, similar to IDS, but can also block or stop the threats in the real time, which is often integrated with firewall. Example, Extricata IPS blocks malicious IP trying to exploit a web app vulnerability. And third is that network traffic analysis. So here, network traffic analysis, the tool uses the Zeek, which is formerly called as Pro. And here it inspects the deeper traffic behavior, not just the signature, which can also detect the anomalies like sudden data upload to some unknown external server or output communication, example SSH over port 80. And last one is that SIEM, that is Security Information and Event Management tool. We have to collect and analyze the logs from different sources. We have to use some correlation rules or machine learning and alert. So popular SIEM tools like Splunk, IBM QRadar, ELK Stack, that is Elasticsearch or Logspatch and Kibana. If a user logs in from India and 5 minutes later from Russia, SIM raises a geolocation anomaly alert. So that is one of the example. In real world cloud attack scenarios, like the first attack is the Capital One data breach, which occurs in 2019. So attack type is that misconfigured firewall and insider exploitation. So what happened is that a former AWS employee exploited a misconfigured web application firewall to gain access to Capital One's AWS environment. Over 100 million customer records were stolen, including social security number and bank account details. So from this, we can able to avoid by regularly audit cloud configuration, or we have to implement some strict access control and least privileges. Yes, something like that. If you're using now, we can able to avoid in the future. Second one, Tesla cloud cryptojacking. So the attack type is that unauthorized resource usage. So what happened is that which occurs in 2018. Attackers gained access to Tesla's AWS environment through some exposed Kubernetes dashboard. They use Tesla's cloud infrastructure to mine some cryptocurrency. The lesson which they learn is that we have to secure the DevOps tools and management interfaces and monitor for some abnormal resource usage. Okay, next one. Uber data breach, which occurs in 2016 but reversed in 2017 because that's a credential theft. Hackers stole like AWS credential from a private GitHub repository, and they accessed the cloud server and extracted personal data of 57 million users as well as drivers. So if you are using some code repository, right, it will be never stolen, and we have to use some secret management tools. And another case is that in 2021, Microsoft Azure Kairos DB vulnerability. So here the attack type like cloud service misconfiguration vulnerability. So what happened is that security researchers found a flaw in Azure's Cosmos DB that allowed unauthorized access to database of multiple customers. So here we have to be updated with some vendor security notices, which enable like logging and audit trials to detect some suspicious activity. Okay, and the last one is that in 2014, that occurs some code space attack. This is a ransom and destruction. So what happened is that hackers gained access to some code spaces, AWS account, and deleted most of the data and backups when the company didn't pay a ransom amount. So the company should have the permanently. So you have to use some identity access management rules with some least privilege. and also have some offsite backs in order to reduce these kind of uh, avoidance in the future. Okay, so these are the real-time scenarios where it is commonly applied. Okay, next topic is that monitoring for unauthorized access. So here they have predicted some diagram. So here some intrusion detection system will be there. Some malicious attack, if they are going through a system, it has to be passed only through the particular firewall. Then there will not be any unauthorized access and there will not be any malicious traffic. Okay, so this is all about monitoring for some unauthorized access. Okay, next topic is that detection techniques. So what are the detection techniques available is that three mainly: a signature based detection, anomaly based detection, and a behavior analysis, which otherwise called as UEBA, that is user and entity behavior analytics. So first one, a signature based detection. So here what it will be doing is that user known attack patterns, right? And some fast and accurate for some known threats. And limitation is that we can't able to detect some new threats. Okay. And anomaly based detection. So here it learns some normal behavior and detects the deviation and uses some machine learning or behavior baselining. Example, a user who normally uploads 1 GB of data suddenly uploads 50 GB at night. So that is not possible, right? So in such cases, we have to go for some timer keeping and behavior analysis. As I told, like we have to track the behavior of the user or the devices and find the suspicious action. So example, like admin accessing the database tables they have never touched before. Okay, and other key techniques which is used in the cloud environment is that what is that, like intrusion detection system or the intrusion prevention system. Okay, and apart from that, uh, like detect some unauthorized access or unusual behavior. Application example, if you take like AWS guard duty or uses some IDS or IPS techniques to detect the port scanning or attempts to escalate the privileges within an AWS environment. And security information and event management, that is SIEM, which aggregates and analyzes logs from various sources. An application example is that so Azure Sentinel, which collects the logs across the services and applies AI to detect the potential threats like brute force login attempts or data exfiltration. And behavior analytics, it establishes the baseline behavior and flag deviation. Application example like Google Cloud Chronicles to detect anomalies like a user downloading large volumes of data outside the business as. Okay, that is also one of the detection. And anomaly detection using machine learning. So use AI to detect some unusual patterns that may indicate attacks. Say application like Splunk or Datadog use some ML to recognize the behavior not matching normal usage like sudden spikes in API calls. And then endpoint detection and response. So here in EDR, which monitors the endpoints, that is VMs container for threads. An application example like CrowdStrike Falcon on AWS detects and responds to malware or ransomware attempts within the cloud hosted workloads. And next is that log and audit trail analysis, which tracks the changes and access attempts over the time. An application example is that so AWS Cloud Trail tracks all API calls, helping security teams to detect unauthorized resources, access, or configuration changes. And honeypot and deception technology, which traps attackers with some fake system or services. An application example by deploying some fake databases or SSH endpoint to observe attacker behavior without risking some real assets. And continuous compliance scanning. So here it ensures configuration aligned with some security standards. Example like Prisma Cloud or AWS config. It will be using all these kind of stuff. Okay. Next one is that we are going to discuss is about uh, monitoring techniques and tools. So first one is that IDS, that is intrusion detection system monitor the traffic for the suspicious pattern and known attack signature. So they can also trigger or when the potential threats are detected. Okay, so there are mainly two types. First one, like network-based intrusion detection system and host-based intrusion detection system. So network-based intrusion detection system which monitors the network traffic, and host-based intrusion detection system is that monitoring activity on some individual unit. So that is meant by intrusion detection system. And so as I told, example like for NIDS, like detecting port scan or some DOS attack, and host-based intrusion detection system. Example like detecting file modification or unauthorized access attempts. Okay. And what about how does this IDS works in the cloud is that, so first one, by through traffic monitoring, which inspects the traffic between the cloud services, instances, or the containers, and rule-based detection, which uses a known attack signature, and anomaly-based detection flags abnormal behavior by comparing to a baseline. And alerting and logging is that sends alert for some suspicious events or keeps logs for analysis. Okay. And cloud-based IDS tools, example is that like in AWS, Amazon Guard Duty, right? For intelligent threat detection using machine learning. And for Azure Defender, you can use some integrated threat detection and HIDS features. And GCP Cloud IDS network-based intrusion detection system using Palo Alto Network Stack, and it's an open source option where it is used in some cloud hosted VM as well as a container. Okay. And real world scenario for this intrusion detection system is that a company running on an AWS which detects an unusual spike in traffic targeting a specific EC2 instance. Amazon Guard Duty flags it as a port scan. So the security team uses this alert to block the IP and investigate further. Okay, so we have to deploy the IDs at multiple level, network and host, regularly have to update the signature and combined with the sign to for better visibility as well as response, as well as we have to integrate with the automated response in order for the quick uh, application. Okay, so next one is that intrusion prevention system, that is IPS we used to say. So here in intrusion prevention system, IPS go beyond the detection by actively blocking some malicious traffic and preventing attacks. They can take actions such as terminating connections or blocking some IP addresses. So what are the key functions of IPS if you take? Like traffic inspection, which monitors the incoming and outgoing traffic. Second one, threat detection. So here it uses signature, heuristics, and behavior analysis, and real-time response. So here it automatically blocks the malicious traffic. Example, drop the packets, shut down the session, or logging and alerting, which keeps the records and alerts admins of attempted intrusion. And what are the types of IPS? Same thing as we have seen in IDS. So here also network-based IPS and host-based IPS. So network-based IPS is that which is deployed at some network entry points to stop the threats before they reach the internal resource. And host-based IPS which is installed on some individual servers VM to protect some specific workloads. So IPS in cloud, how it is used is that which is integrated with a virtual firewall or load balancer, a cloud gateway, which is often paired with some web application firewall and SIEM tools, which helps to prevent a DDoS attack or malware and brute force login attempts as well as much more. Like real world scenario means a retailer's company e-commerce site is under a SQL injection attack. So their IP is running on an Azure firewall or detects and blocks a malicious payload before they reach the app server. Okay, so logs are sent to the Azure Sentinel for the analysis. Okay, and next is that like what kind of practices you can go for IPS in cloud is that we can able to deploy at the critical network choke points as well as if you use updated signature and custom the uh, rules, okay, and then combine with IDS and SIEM 2 for complete visibility and as well as for for instant response. And you have to test the IPS rules to avoid the blocking of legitimate traffic. So this is all about IPS. Next one is that SIEM 2, security information and event management. So here SIEM. So this system collects and analyzes security logs from various sources, providing a centralized view of security events. Okay, they can correlate events to identify the complex threats and generates the alerts. Okay, and so this SIEM which is used to detect, investigate, and respond to threats in the real time. So the core or the main functions of SIEM is that log collection, event correlation, real-time alerting, incident investigation, compliance reporting. So what is meant by log collection? Which is gathers the log from cloud services, servers, application, firewalls, and endpoints. Okay, and event correlation is that connects a related security event to detect some complex attack. Example, failed login or the data download, which is a possible account compromise. Okay, and real-time alerting is that which notifies the security teams of suspicious activity. Okay, and apart from that which instant investigation, and also if you take provides tools to trace the attacks step by step, and compliance reporting is that generates the reports for regulation like GDPR, HIPAA, PCI DSS. And SIEM in the cloud, how it is used is that which monitors the cloud infrastructure. Example, AWS, Azure, as well as GCP. Analyze the logs from the VM or the container or the API and supports the hybrid environment. And popular SIEM tools for cloud is there like Splunk, Azure Sentinel, IBM QRadar, Elastic and Log Rhythm. And if you take the real world application, in an MNC that uses Splunk to monitor the AWS cloud trial or the VPC flow logs and application logs. So it also detects a pattern of failed login attempts followed by a successful login from a foreign IP address and immediate download of large volume of data. So Splunk raises an alert and the SOC investigates and revokes the user's credential. So what are the benefits of using SIEM in cloud is that it's a centralized view of all cloud and on-premise security events, early detection of insider threats and external attacks. And it's a faster instant response as well as forensics and helps to maintain continuous compliance. Okay. So this is all about the sign. So this is a very important topic in case of cloud security. Okay, so next topic is that a firewall. So we all know like firewall, it is a which controls the network traffic by filtering incoming as well as the outgoing connections based on some predefined rules. So they can also block some unauthorized access as well as a malicious traffic. So what are the types of firewall available? Yes. So network firewall like web application firewall or next generation firewall. Okay, and then host based firewall. So first one, network firewall controls the traffics based on the IP address, port, or the protocol. Examples that AWS network firewall or Azure firewall. And web application firewall is that it protects web apps from common attacks like SQL injection or accesses. Example like AWS WAF, Cloudflare, Azure WAF. And next generation firewall. So here it includes features like a deep packet inspection, intrusion prevention, application awareness. Example Palo Alto VM series, a Cisco secure firewall. The next one is that host-based firewall, which runs on an individual VM or a container. Example like Windows Defender or a firewall. And firewall use cases in cloud, like what is the use cases is that we can able to restrict the access to the management port and segment networks using security groups and subnets and protect the API as well as the web apps with WAF and limit the access to database which is only specific to the services. Okay, and AWS, which was a group like security, WAF, Azure industry, GCP cloud armor or hybrid party can go for some Fortinet, Cisco, all those stuff. And real world scenarios that a healthcare provider uses Azure firewall to segment the workloads or the public web server in one segment and patient data in another. So only HTTPS traffic from the web server is allowed to the backend via some defined rules. Okay. So a WAF also sits in front of the app to block some injection attack. Okay, so this is all about the firewall. So next we are gonna discuss is about UEBA. So that's nothing but user and entity behavior analysis. Okay. So here user and entity behavior analysis means uh, to establish some baseline or some detect the anomalies and they can identify some suspicious activity that may indicate compromised accounts or insider threats. Okay, like what are the main functions of UEBA is that so here in UEBA like it has some core function. First one, behavior profiling. So it establishes a baseline of typical activity, example login or IP addresses or resource access pattern. And second one, anomaly detection, which flags the deviation from the baseline. Example, a developer account suddenly download a large data set at 3 a.m. And risk scoring. So assign score to anomalous activities. Higher scores indicate higher risk. Okay. And contextual correlation. So correlates events across multiple entities to identify the sophisticated attacks. So how does the UEBA works in the cloud is the first one, data collection, profile building, continuous monitoring, and alert and response. So data collection, you all know, ingest some logs or metrics from IAM services, application, VM container, and all those stuff. Profile building uses a machine learning to model the normal activity for each user and entity. Okay, and continuous monitoring is that which monitors the events in real time against the learned model. And what is meant by alerting and response, which generates alerts with risk scores and context, feeding into sign or source for automated or manual investigation. And real world example of using UEBA is that a financial services firm notices a mid-level analysis service account normally accesses transaction logs during business hours. So UEBA flags a series of hours bulk downloads of customer data from an unusual IP and elevates the risk score. So this is called as a real world example. And the benefits of UEBA is that early detection, insider threat mitigation, reduced false positive, and then forensic context. Okay, so this is all about UEBA. Next one we are gonna see is that NTA, that is network traffic analysis. So what does it mean network traffic analysis is that NTA tools deeply inspect network traffic to identify the malicious pattern as well as anomalies. Okay, so they can detect threats that may evade traditional security tools. And the core functions involved in NTA is that network capture and flow connection, protocol and payload inspection, and behavior baseline and anomaly detection, threat hunting as well as forensics. So how does this NTA, that is a network traffic analysis, works is that there are four main steps. First one, data ingestion. Second one, enrichment. Third one, analytics engine. And last one, alerting as well as integration. And popular cloud NTA tools like it goes for Azure or GCP or multi-cloud or AWS Azure, okay, and then Azure or GCP, something like that. And what are the real world use cases that uh, SAS provider notices occasional spikes of east-west traffic within the microservices that don't normally communicate. So the NTA tool alerts on an unexpected protobuf encoder stream and which investigates triggers an attacker exploiting a zero day in an international API to exfiltrate customer data. Okay, so the SOC quarantines the affected instance and patches the vulnerability which stops the data loss. And best practices for cloud NTA is that enable flow logs everywhere, centralized traffic collection, and correlate with some INT as well as assert data, tune the baseline periodically. Last one, you have to integrate with some orchestration. Next is that log analysis. So what about log analysis is that regularly we have to view, okay, not like that, we have to leave, we have to go for it, we have to regularly update the uh, casualty. So that is the log analysis, and which can reveal the sign of an unauthorized access or some malicious attack. Okay, so that is all about log analysis. And last part we are going to discuss is about endpoint detection and response. So here, EDR system monitors the endpoint for malicious activity, providing a real-time visibility and response capabilities. So this is about monitoring techniques and tools. We have discussed about IDS, IPS, sign tool, firewall, UVBA, NTA, log analysis, and last one is that EDR. Okay. Next is that the types of malicious activity detect. So if the threat type is support scanning, the description is that attacker scans the open port on a server, and detection is the method is that IDS, it can be a fire log, okay, and brute force attack in the sense repeated logging attempts to guess password. So detection method uses that sign or OSSEC, and if it's a phishing or malware threat, You can go like email or a web-based malware downloads. You can use the detection method like IDS or email gateway. And command and control, that's C2. Malware contacting its controller. A reduction method like NTA or Zeek. Okay. And threat type like data exfiltration. So description like sensitive data sent out secretly. Okay. A detection method like anomaly detection, you can use it. And next threat type is that DDoS or DDoS attack. The description is that overwhelming traffic to the disrupt service. I can use the detection method called firewall or IPs. So these are the real world example scenario which we have discussed. So like a firewall logs the repeated login attempts, the ID is not, it's used to known brute force pattern, and sign, which is a Splunk monitoring tool which correlates the logs from the firewall, web server, and OSEC. An alert is triggered where the brute force attempts on admin login. Okay, and IPS, which blocks the attacker's IP address. And next one is that admin receives the alert and reviews logs for deeper analysis. Okay, so these are the real world example scenario for monitoring as well as the traffic for malicious activity scenario. So in this particular video, we have discussed about monitoring for unauthorized access and malicious traffic, and what are the importance of monitoring strategies for effective monitoring. Have seen the 5 monitoring aspects and key components involved, and the types of malicious traffic detected, and tools for detection and monitoring. Yes, and the various detection techniques, and we have discussed about the types of malicious activity detected. I hope you all had a clear idea on this topic. So we will see in the next video. Thank you all.